Hello students, in this question it is mentioned that a body of volume 100 centimeter cube weighs 5 kilogram force in air. So its volume is given 100 centimeter cube and weight is given 5 kilogram force. Okay, kilogram force is gravitational unit of force. Okay. So it is completely immersed in a liquid of density 1.8 into 10 raised to 3 kg per meter cube. So we need to find the upthrust due to liquid and the weight of body in liquid. So this weight of body in liquid is also called as apparent weight. So we know that the formula for upthrust. So we can write upthrust is basically upthrust is equal to the weight of liquid displaced by the body. So we can write upthrust is nothing but the weight of liquid displaced by the body. This is called as upthrust. Okay. Or you can write upthrust as volume of the solid inside the liquid. So volume inside into density. Here I am writing rho. Rho is the Greek symbol for density. So density of liquid into acceleration due to gravity. This will give us the upthrust. Okay. So here volume inside is given as 100 centimeter cube. Okay. So to convert this into SI unit, so we can write it will be 100 multiplied by 10 raised to minus 6 meter cube. This will give us the volume, okay, because the body is completely immersed, okay, and density of liquid is 1.8 into 10 raised to 3 kg per meter cube, and G we can write as G because we can give our final answer in kgf, because here they have given the weight in air in kgf. So the upthrust also will write in kgf, and the final answer for the second part, the weight of the body in liquid, also we can write in kgf. Kgf is kilogram force. So when you solve this, it will be 1.8 into 10 raised to minus 1 kgf. Okay, or you can write 0.18 kgf. So here upthrust will be 0.18 kgf. Kgf is kilogram force. Okay, this is the answer for first part. Now in second part, we need to find out the weight of body in liquid. So here we can write weight of body in liquid. So this is also called as apparent weight. So apparent weight will be weight of body in air. So weight in air minus upthrust acting on the body. Why it is so? So for example, suppose there is a container. So whenever a body is submerged in the container, so weight is acting downward, mg weight is acting downward, and upthrust or buoyant force is acting upward. Okay. So the apparent weight, the weight which appears whenever a body is inside the liquid, is always less than its weight in air because of upthrust. So since weight is acting downward and upthrust is acting upward, so net force or resultant force in downward direction, that will be called as weight of body in liquid. Okay. So here weight in air is 5 kgf. So 5 kgf minus upthrust is 0.18 kgf. So the weight of body in liquid will be 4.82 kilogram force. Okay. So this kilogram force you can convert into Newton as well by multiplying it with the value of G. So G here you can take 9.8, okay, to convert this into Newton. So like for upthrust, it is 0.18 kgf. So in Newton you can write as 0.18 into 9.8 Newton. Whatever answer you get, you can add this value, or approximately you can take G as 10. So your answer for upthrust will be 1.8 Newton. Similarly, when you're taking G as 9.8 for the weight in liquid, So your answer will be 4.82 into 9.8 Newton. But if you are taking G as 10, so it will be 48.2 Newton. Okay. So that's all. This is very simple question based on the formula only.